Welcome back. Last video we encountered a problem when trying to connect to our database, and I figured that out. It was my mistake, obviously. I used curly brackets in here and basically just use parentheses. Normal parentheses works in here. So I was afraid that there's a syntax error. I can now sleep very well knowing that there is a syntax error, and knowing that I'm doing this as a hands-on experience, I believe that's fine, and we're learning by doing. So after we've changed that, we obviously need to do kubectl apply -f python YAML. And that will change the pods now. So actually, let's double check in here. It's now creating a new container and the old one is still running. There is a reason for that, because Kubernetes will not kill that container until that one is up. So now this is running and the other one is terminating. We can actually take a look at the logs, kubectl logs. There we go, that works. And we can do the exec that we did before. Sorry, let's move this up. We exec python manage py migrate. It works, nice. Cool. And we're also gonna create us a super user. There we go. I don't want this to be root. I want it to be called super user. It will have a secret password. There we go. And now let's access the Django admin panel, right? There's nothing easier than that. Well, it is a little bit complicated now. As promised in the last video, we need to create a service and we need to expose it. So right now we don't have a service at all. We could do it by using kubectl port forward. I need to look up the syntax again. There we go. When we don't want service Postgres, we want service. Actually, we don't have a service. We have a deployment. What is the deployment called? It's probably called tickets. And we want to go to port 8000. All right. Let's see what happens. This actually worked. Didn't expect that to work, to be honest. We actually get our app, so we can log in, we can sign up if we want to. That's okay for what we want to do right now. And if that is all you wanted to achieve, thanks for watching, and go on. If you actually want to have a real deployment with Kubernetes, you need to keep watching now. So if we actually open the admin panel now, the first thing you will notice is there's no CSS applied. Weird. Let's log in and investigate on that a little bit. Yeah, there's really no CSS applied at all, and no images, nothing. This is because we don't have static files delivered by Kubernetes. This is what in our Docker Compose YAML, or actually in our prod YAML, this is why we had the Nginx server with static files. Obviously, we could do the same now too, but to be honest, this is kind of, yeah, you need a volume. It's not like, I don't know. It's not the way to do with Kubernetes. What you could do, the way to do if you want to do it like really sophisticated, is you use Amazon S3 or another CDN provider where you have an upload to your for your static files, and you serve your static files via that, and you set static URL in your config. A much easier way for our setup, although, is white noise with Django. So if you take a look at white noise, it says radically simplified static file serving for Python web apps. Essentially, it's the same as what you would do with Python manage py run server. With debug true, it serves the static files. The same is gonna be true if we just use white noise. So what we're gonna do is we're gonna look up at pipe white noise, and it will tell us that white noise is available in version 5.0.1, so we're gonna add it to our requirements. You could say you can add it to our prod requirements now. I don't know. I like this in my base because I want to use this as a default so I can test it locally. So we're going to use 5.0.1 and we're going to go smaller than 5.1. We are going to do a Docker build of our prod Python Docker file. We're going to set a new image tag now. It's going to be 1.1. Although I did forget something, before we do that, we need to follow the tutorial, obviously. There is a tutorial for white noise. Basically, it tells us add white noise middleware in your middlewares after security middleware. So let's do that. Tickets, settings, space py, middleware, security middleware. There's our security middleware. All right. And we need to say static files need to be, so we don't need that. Or we can enable that, but it will cache files and I don't want that. I think that's enough having the middleware in here and having the Docker built. Sorry, I'm in the wrong directory again. There we go. Now we're building version 1.1 of our Docker file, of our app, so to say. We added white noise. I want to show you one nice thing now. You don't always need to edit your deployment YAMLs that you have in here. So this one, for instance. Obviously, don't get me wrong, you should edit it in here and then apply it. Sometimes you want to do some troubleshooting. Sometimes you want to do some editing. You want to debug something. You want to try something out. And maybe you just want to try the new version of your app without like committing to your Git repository. And there is one nice thing you can do. And it's really, really nice for troubleshooting. It's called, I'm going to leave the port forward open, by the way. I'm going to go to a new tab. It's called kubectl edit. What we can do is we can edit the deployment. What is it called? Tickets. In the meantime, while I'm here, the building has finished. I'm going to push this image. See Kreuzberger tickets 1.1. So we're going to edit the deployment tickets. What we get is a VI. And I don't like VI. If you want to exit it, press escape, Q. If you've changed anything, you should use Q, and I think like this it should work, yeah. All right, the image has been pushed. So we don't want VI to edit, we want nano, because I don't like VI. I'm a hands-on guy, I like nano. No, you can use whatever you want. Edit deployment tickets. You can also add kube editor equals nano to your bash or C or whatever environment, but yeah, that's beyond this tutorial. Anyway, we have the deployment YAML here, and we have it in an editor that I can use. I'm just not skilled enough for VI. We need to take a look. Where is the image? There is the image, and we want to upgrade the image to version 1.1, and we save it. And it says it has been edited, and what we should see now is, there we go, a new container is being created. The old one is still running, although that's fine. And after some time, it is running now, and the old one has been terminated. Probably our port forwarding is not working anymore. We will find out soon. Yeah, it's telling us it's not forwarding it anymore, so we need to Control-C it and forward again. We don't have static files. Why don't we have static files yet? It's actually quite simple. We didn't follow the whole tutorial. I should have read it. Essentially, we need to call... I should have looked into that, yeah. Essentially, we need to enable it, and we could have used compression support. Don't need it. 1 second. I think I need to call collect static ones. Yeah. It tells me that here, as part of deploying your application, you'll need to run manage py collect static to put all your static files into static root. This is an oversight of me. Apologies. essentially what we want to do is in our Python Docker file for prod. Well, we don't use the entry point in here at all. What we want to do is we want to call we want to call collect static. Yeah. This is not as simple as just calling collect static in here. We could do it in here though. So we're gonna say, actually, I'll leave it as I'm gonna do Python. Come on, manage py collect static. I think -y will say yes to anything, and we're gonna define that we want to use the entry point. Let me just see. This is copy chmod and entry point. Copy and entry point. Copy. I need to copy the correct entry point although, so I need to copy the prod Python entry point. There we go. And we're building it. I did make something that's like, I added the entry point at the bottom now just to speed up this build. In this case is not what we learned in another video. I should have put this above the work there, so right there, but that's fine. I can do that afterwards. But this will ensure that collect static is called before we run whatever is being ran. So what do we need to do to get this running now? We need to delete that pod. So kubectl delete pod. Doop. It will delete the pod, and it's terminating. It's creating a new container, and we'll see what happens. And the container is up and running. I need to cancel my port forwarding and redo it. And I hope it's working now. No. Not working yet. What did we do wrong? Did we not repull the image maybe? Wait a second, what did we do? We copied the prod Python entry point, we called it. It should be running, Let's actually check the logs. That's the simplest thing to do is to check the logs, because if something went wrong with doing entry points, I just copied this character. Yeah, apparently collect static does not accept the -y parameter that I wanted to have, unrecognized argument. So check the logs. That helps a lot. Let me just double check what they say. Collect static -y. All right, I'm not finding anything, so I did think that you need to specify like a -y option, but it doesn't look like there is such a -y option, so whatever, I just removed that, and we're gonna rebuild the image, we're gonna, god damn it, we're gonna rebuild the image, we're gonna push it again, and we're just gonna kill the pod again. By the way, the nice thing about pushing is it will tell us that layers already exists, and the same thing is true with the caching. So this is quite fast, and I like it when things don't take too long. Kubectl delete pod, and it should be terminating, and it should be creating a new pod, and we'll be back in like a couple of seconds. And it's finished. Let's double check our site. Yep, port forwarding. There we go. Static is not working. That's fine. Admin. It's still not working. Logs. Now see, this is why I actually had the -y in it, because I wanted it to have like the yes, but apparently it's not there. Let me fix that offline. I'll be back in a second. So I figured it out. It's basically a reading issue again, and minus minus no input is the correct parameter. So I had minus minus yes. I actually wanted minus minus no input. Now I have minus minus no input, and we're gonna build it again, and we're gonna push it again, and we're gonna delete the pod again, and I'll be back in a second. All right, I figured out what was still missing. So to summarize what my mistakes were, I forgot the minus minus no input in the collect static in my entry point. And in my settings, I needed to define a static root because it needs to put the static files somewhere when it does collect static. That's also something that it would have told me in the log. So I used kubectl logs again for the pod. And it does tell me here, improperly configured, you're using static files without static root. So I did set static root. I published the image again, restarted the pod. What can you tell? Here we go. Everything is there. So now we have a Django admin panel. Now, as a very last step, let's get rid of this annoying port forwarding that we need to do all the time. So this is what we created the Python ingress.yaml file for. And essentially what we need to do is we need to do the same that we already did with our Postgres deployment. We need to create a service. And creating that service is quite simple once my IDE lets me do it. There we go. We just copy that in our Python ingress. All right. We need to make sure that we have like the same thing here. We're gonna call it tickets. This is tickets. Selector is, I think, tickets. Port is 8000. In the case of cluster IP, it would be 8000. But what we actually want to do is we don't want to use cluster IP. We want to use load balancer. I actually have that open somewhere. Give me a second. No. I thought I had it open already. It's okay. We want to use load balancer in here. And we can use it like this, and it will open us port 8000. So let's go kubectl apply -f deploy Python. Yes, you can also use a path in here. Python ingress. And to verify that it works, or probably it doesn't work, is we can use kubectl get services, and it will tell us tickets is using load balancer, the cluster IP is this one, and the external IP is pending, and it would map port 8000. Cool. However, we can watch this. It will never really work because there's one big issue that we forgot to do is we forgot to use Minikube tunnel. Minikube tunnel is a load balancer that is running on your local computer and is connected to Minikube. It will ask you for the password because it uses sudo in the background, so it will ask you for the password. That's fine. Once we've started that, it should tell us, yeah, actually I was quick. There we go. We got an IP. Now, this is the same IP as it is right there. Don't get me wrong. There's like no fancy magic load balancer involved. It's basically just something that acts as a load balancer towards the Kubernetes API. But if we access HTTP that port 8000, yep, we get our app. And just to verify, I can stop the port forwarding now. I will exit that window of the port forwarding. The app still works. I can log in as a super user, and I can, there we go. All my static files work. They are basically served from static via white noise. And that's basically it. We have the load balancer set up. Now, the only thing you might wonder, and you might want to do is you don't want port 8000 for your load balancer. I mean, seriously, you want to have port 80 and probably even SSL. So let's apply this updated ingress again. Let's see what's going on in here. It already changed. Okay, so is the IP the same? 11? Yep. Let's remove that. No, it's not letting me do it. Nope. So maybe I cannot use port 80. Maybe it's, sorry. It's obviously, I think, is it node port? Target port. Target port is 8000. Obviously, if you don't define the target port, it's going to assume the target port is 80. There we go. And I hope with that you've learned something. Most definitely you've learned the mistakes you can make with white noise, the mistakes you can make with load balancer, and the mistakes you can make with entry point scripts, etc. So, and how to debug entry point scripts using logs. So one last final word, the secret key that we have right there. I don't want this to be in my Git repo, so we are going to add this to git ignore. Deploy python this.yaml. Perfect. This is in git ignore. And with that, git add, git commit, add python Django deployment with load balancer. All right, so in this video, we have accomplished to publish our Python app using a load balancer. We could have used node port as well, but we want to use load balancer for this tutorial. It's published on port 80. Just be aware that often you don't have the ability to publish on port 80, depending on the system you have. It doesn't use SSL yet. That's a completely different story that I'm not going to cover in this tutorial. Feel free to Google for it. You'll find various options, to be honest. So there is like no good option available that you would recommend all the time. It depends on your hosting provider. Other than that, we have the Django app running. Feel free to play around with it. One last thing. Sorry, that was the wrong window. One last thing that I want to show you is how to scale up your app, because that was one of the things that we had initially. I need a new window again. We do kubectl edit deployment tickets, and I do kube editor equals nano, and we're gonna move down to where it says replicas. We're gonna set it to 2 and save it. And what you should see now is you see a second container, a second pod is coming up now. And it's just being served by Kubernetes. There's nothing we're doing right now. Like this is like all happening by Kubernetes. If we refresh the page here, it's working. And how do we verify which container is actually responding? Let me see if we can do a kubectl logs deployment tickets. I think it's this. Yeah, there we go. And -f for follow. I'm not sure if we can, no, we actually can't see which one is serving the response. But in the background, it's a round robin scheme, I think. So this pod is serving, and then this pod is serving, and then this one is serving. So we can basically put a lot of load on this now, and it should work. It's both pods are serving the requests, and this is the nice thing about Kubernetes, and this is the nice thing about having a cloud native app or a 12-factor app, whatever you want to call it. You can now just scale it up almost limitless. I mean, there is some limits, don't get me wrong, but you can scale it up nicely. That's the point. And you don't need to implement any fancy things for scaling. You don't implement anything for threading. That's all being handled by Kubernetes and by Unicorn in the background. So, and once you don't want that deployment, or once you say you don't want 2 replicas, you want to go back to 1 replica, you just use kubectl edit deployment again. All right. That's it for now. Stay tuned for the next part of this video, where we're gonna see how we can get RabbitMQ running, and then afterwards we're gonna also get Celery running. See you soon.